All right, guys, today we got increasing, decreasing, and piecewise functions. 2, 3 different topics there. Hang in there. We'll be fine. First of all, increasing, decreasing, and constant. Increasing is when you're looking at your graph from left to right, going that direction right there. Is the graph going up, or is it going down, or is it just staying flat? If you look at this first one right here, the red parabola, it is increasing from forever to the left. Remember, we're going to the left up until it gets to this point right there, and that point is -1,5. And because we're looking from left to right, it's increasing from -infinity to -1. We're going to use our x coordinates. That's where it's increasing. Then it starts right there at that same point. It starts decreasing. It starts going down. So we're going to say it decreases from -1 to forever. Again, left to right. You're looking at your x-axis. Use your x coordinates when you talk about this kind of stuff. Let's look at the second one. Second one, it's decreasing from, well, I'm trying to draw on it. It's decreasing from there to there, going down. So that means it's decreasing from forever left until it gets to 2. Remember the x, we're looking at our x coordinates, looking left to right. It starts increasing at 2 and increases forever the rest of the way. So it's increasing from 2 to forever. And the last one right here is just flat. It's a horizontal line, which means it's constant. As you can see the word right there, it's constant forever. So we say it's constant from -infinity to +infinity. Again, when you're looking at increasing, decreasing, or constant, you're looking at your graph from left to right, not up and down, but left to right. So we're using our x coordinates to describe it, and because the x-axis goes left to right. All right, here's one more. This is what your homework's going to look like. So it says determine the intervals in which function is increasing, that's part A, decreasing, which is part B, and constant, which is part C. Now it's increasing. The only place I see it increasing is this area right here. It's going up right there. So remember, we're using our x's, we go left to right, so it's increasing from 3 to 5, and that's all. It's decreasing from here, it keeps moving on me. It's decreasing there to there, which is from forever left until I get to -1. And it's also decreasing right here, which is beginning at the 5 and going forever. So I'm going to put 5 to forever. So it's decreasing 2 places. And it's constant right here. It's constant between those 2 points. And remember, we're looking left to right, so use your x coordinates. It's constant between -1 and +3. And that's all there is to that. They're going to ask you just those questions. Where's the increasing, decreasing, constant? Use your x coordinates because you're looking at it from left to right. All right, relative maxes and relative mins. A relative max is just the bottom of a valley or top of a hill is a relative max. It's called relative because it's not absolute max or absolute min. Like this point right here is a relative min because it's a minimum on the graph. As you see, as it goes down, hits the min, then goes back up. This point would be a relative max, obviously, because it is a peak, and another relative min is right there. You can have as many relative mins or relative max as there could possibly be. We're actually going to find these tomorrow on a calculator, and I'm going to show you those steps tomorrow when you come to class, so make sure you have a calculator with you. You always do, but make sure you have it with you, and I'll show you how your calculator will find those for you. I'm going to see a few applications today, so I'm going to show you one here. It says Elena and Thomas drive away from a restaurant at right angles to each other. That's the picture. And Elena's speed is 35 miles per hour and Thomas is 40 miles per hour. Express the distance between the cars as a function of time, and then find the domain of the function. So that's what we're going to do. Now, if you look at the picture, it's a good picture, or kind of a good picture. I hope you can see it. It says they left at a right angle. And what happens, because they left at a right angle, their distance is the distance they are apart from each other, this distance right here. And so what we have is a right triangle. So their distances would be the hypotenuse of a right triangle, which is C. Or in this case, it's said to use this right here. It's said to use D of T. So I'm going to use for the hypotenuse. So I'm just going to do Pythagorean theorem and see what we can come up with there. So let's see what happens when we do that. If I can get the problem fixed back. All right. So part I can just do Pythagorean theorem. D of T, which is really the y, or the hypotenuse, squared. Let's do this first. The distance, how far did they go? The distance, Elena went this far. Distance is rate times time. We don't know how long they were gone. Thomas also went rate times time. He went 40t. So I'm going to take the 35t and square it. I'm going to take the 40t and square it. and just work that out. So on this side over here, I still have my d distance time squared. If I squared 35t, I'm going to do my calculator real quick for that one, the square root of 35. Should know that in my head, but I don't. 35 squared, 1225 t squared. I do know 40 squared is 1600 t squared. So I get this, I get the distance t, that t squared is 18 or 28, 25 t squared. So I'm going to take the square root of both sides to give me my function here. I'll take the square root of 28, 25. I get 53.2 t. So there's my function right there. All right, that's the answer to part A. So just want to find the distance between the car as a function of time. So however long they're gone, they're going to be that far apart. 53.2 times how many hours are gone. And then for part B, it says find the domain of the function. With the domain, time has to be positive, obviously. So because time has to be positive, my domain is going to be greater than or equal to 0. So I'm going to put my domain is going to be time is greater than or equal to 0. Or we could write it like this, 0 to infinity. And that's actually better and quicker. And that's all they want there. And you're going to see a couple of those in your assignment tomorrow, so be ready for that. And the last thing we got today is piecewise functions. I'm going to do two things with them. First of all, they're going to give you some numbers just to plug into the piecewise. They're called piecewise because they have different pieces to them. They're going to ask you to find some values, first of all. Whenever you see something like f of -5, you know what that means. Take the -5 and plug it in. So what I'm looking for is where do you plug -5 in? Well, I'm going to plug it in here because -5 meets that condition. It is less than -2. So if I plug -5 in for my x, I get -4. And that's all there is to it. -3, if I'm going to plug in f of -3, -3 is also less than -2. So I'm going to plug it in here. -3 plus 1 is -2. 0 is next. Plug in 0. Where does 0 fit? 0 fits in here. 0 is between -2 and 3. And it says anytime that happens, you plug it in there, you're just going to get 5. F of 3. 3 is, that says -2. It says less than or equal to 3. Because it says equal to 3, I'm going to plug it in there also. And I'm also going to get 5. F of 4. 4 fits down here because 4 is greater than 3. So I'm going to plug it in for that x. 4 squared is 16. And the last one is f of 10. 10 is also greater than 3, so I'm going to plug it in there. 10 squared is 100. That's all you do. Figure out where you plug them in and plug them in those based on the domain. This is the domain over here on the right-hand side, or your restrictions, where you put them in. And the last thing I'm going to have you do today is just graph piecewise. And don't make this any bigger deal than it is. Not that big a deal. You're just going to graph 3 pieces of one function. And that's all you're going to do. So the first thing I have is this part right here, which just says f of x equals 4. Because there's no x, it's a constant. It's a horizontal line. And I'm going to draw it right here. I'm going to start at 0. So I'm going to go to 0, 4, which is here. And because it's less than, I'm going to go left. I'm going to go to the left of the 0. And because it's a horizontal line through 4, I'm just going to draw it just like that. So that's the first part. The second part, right here, 4 minus x squared. That's a parabola. Here's what you need to do. The best way to do is take the number here and plug it in for your x to tell you where to start. So 4 minus 0 squared is 4. So I'm going to start it plugging in 0. And I got 4. So I'm going to start 0, 4, which is the point that's already there. Take the 2, plug it in here. If I plug in 2, I will get 2 squared, which is 4. 4 minus 4 is 0. So I get 2, 0. That parabola, actually the vertex is at 0, 4, and it's going to go down, so it's going to go, it's going to go right to here. But I'm just going to do this much of it because that's all it asked me for. It's a part of the parabola between 0 and 2. That's why I plug those points in. And the last thing I'm going to do is graph this part beginning at the 2. So I'm going to plug the 2 in for the x. 2 times 2 is 4, minus 2 is -2. So I'm going to go to 2, -2. I'm going to put an empty circle there because there's no equal sign with my greater than. And because it says greater than 2, I'm going to go to the right because this is a line. There's no exponent. The slope is 2. So I'm going to start at that point, go rise 2, run 1 to right there. I'm going to connect the dots, just like that. And there's my piecewise function. So there's 3 parts. You just take each part, each piece, I should say, each piece of the graph, and just graph that piece based on what your domain is right here. And the best way to do this is plugging those points in and going from there. And we'll do several of those tomorrow, and I'll help you through. We'll be fine. So look forward to seeing you then. See you. Bye.